So yeah, thank you everyone who turned up today. So we're going to cover OWASP. I think an important thing is just first of all covering what is OWASP in case people are wondering. So OWASP is an open source community based approach. Unlike things like MITRE ATT&CK, it's think of it more of as an awareness aid. So it's a way of like really understanding water in misconfigurations, water insecure configurations, anything to do with application security that you've obviously it's not secure, and giving also like consultative based approach to like how you should solve problems. So I think it's a really useful tool. And again, these findings, these risks, they will apply to everyone's Kubernetes environment. So I guess that's the point, that there are different OWASP T10s you've probably seen. This specific one was launched in 2022, so it's a relatively new thing, and that's why I wouldn't expect everyone to know it inside out. So yeah, why should we care about it? Like I mentioned about MITRE ATT&CK there a while ago, a lot of security teams are going to use MITRE ATT&CK as a way of understanding tactics, techniques, procedures of how an attacker moves within your environment. But it's not Kubernetes specific. So the idea behind the T10 is you're focusing on specific risks that will apply not just any random virtual machine or monolithic architecture, but specifically cloud native workloads. So with that, again, yeah, there's fragmented vendor approaches. Every security vendor tells you how you should do security. This is a standardized approach, and since it's open, there's a transparency for everyone who's using it. So with that, there are 10 different control sections, I guess you could put it, and they cover everything from insecure workload configurations through to networking and secrets management. There's, all of them are visible on screen. We put together this little visualization as a way to understand when we talk about each section, where exactly in your environment does this apply? So for instance, supply chain vulnerabilities apply at the container registry, but they also apply at the host. So again, visually, you'll have the color coding system throughout the talk. So yeah, why are Kubernetes risks so concerning? I'm going to go through this really quick, but the main general reason is things like publicly exposed applications, ephemeral workloads. Again, security controls that traditionally worked on monoliths, like perimeter-based firewalls, don't really apply to cloud-native workloads. So I'm just going to quickly jump through that, and we look at the Kubernetes landscape. Now, Sysdig did a great job as they put together a threat research report, and we took together 22,000 images, and from that information, we were able to tell how people use Kubernetes today. So we know containers are ephemeral. Everyone's aware of that logic, that if they die, they get recreated, and that's really nice. However, not everyone might know that, what was it, 72% live less than 5 minutes. So this is a really important thing. So from all that aggregated information, we can say, look, they're not lasting very long. So if you have like a polling tool and you look at what a configuration was 5 minutes ago or when something was done every 5 minutes, probably it's not going to give you the deep visibility you need. And that's where tools like Falco become useful when we're looking at system call architecture in real time. So the other thing that's worth looking at, again, is the number of vulnerabilities. Since, again, we have real data to apply, we know that of those images looked at, like 83% have vulnerabilities. So it's a big thing that we need to actually take action based on real problems in your environment. And then of those images, we've seen like a crazy number of dependencies that actually have like directly insecure or malicious actors in it. So we look at like crypto mining being one of the most common examples that actually shows up within those images. The other part, and we'll talk about this very soon, is around just general security hygiene. So a lot of organizations, they're running workloads as root, their security context set to privileged. Do they need to do it? Most likely not. Some things do obviously need to run as privileged or with root permissions, but more often than not, you don't need this case. So knowing that 83% of those containers are actually being run as root, it's just really easy for an attacker to exploit those and do further damage and move laterally. So with that, what are some of the most common security risks in Kubernetes? We'll start with insecure workload configuration. I talked about there, like, do you have this huge number of dependencies? A big way to solve that is using like a clear base image, something like Alpine Linux. It's a great example. You can see when we're talking about obviously this is going to apply purely at the application or the pod level. So yeah, using something like Alpine Linux is a good option rather than just dragging in a bunch of dependencies that you don't really understand and therefore need to take action on that. Try to avoid using privileged workloads. And again, same things for file system. You don't want people writing to sensitive data. So with that, here are the examples, because I think it's good that people see how these are configured. You can specify a root level user or actually what is the permission of that user. So what we don't encourage you to do is run as user 0. Instead, specify the actual permissions for that user. The same with the read-only root file system. You should actually be able to specify, read-only permission is the specified flag, so you should say true. And similarly, for privileged workload, you should say false. If you can avoid it, don't do it. A great example is you want to run something like a exem rig. So you're an attacker, you compromise the workload, you want to run a crypto miner, but it needs privileged permissions. If it was a non-privileged workload, if they terminal shell into it, they can't actually do much with it. So again, you want to take away those permissions where possible. Another way of looking at it as well is if you don't make it a root user, then that privilege setting is also not really applicable so much in that case. So yeah, here's the example. So we talked about like 3 examples of insecure configuration. Then you actually need to be able to take action on it. So a great way to do that is using admission control. So with OPA, you can actually, like you can see here on the left, I have that example of a pod deployment where I'm using Alpine, which is great, but I have that privilege set to true, which isn't such a good option. In this case, then you can use something like OPA Gatekeeper. So currently running in runtime, you can actually say, I want to deny using the admission control anything that has, do you see the C option for security context privileged? So if it has that, I want to deny it. I want to stop it from deploying. And similarly, you see in the output where it says that privileged container is not allowed, and then the actual image, which was the Alpine image. So yeah, that's a very good action that you should apply within your environment. And again, everyone can apply this. Then there's Falco. So assuming you don't have something like OPA Gatekeeper, Falco is runtime intrusion detection systems. Think of it similar to Snort. You can create like, these complex rules, but rather than focusing on just network-related activity, you actually have system call architecture. So you can look from networking-related traffic, but you can also look at things like when a pod is created, a process is executed, terminal shell into a workload, any of these kind of things. So in this case, if it has that container.privilege set to true, then we trigger an alert on it. But where you have the nice logic here is you can say, but also I don't want to detect on things that actually do need to be privileged. So things like my Red Hat images, I want to list that macro as the images that I trust and they can run as privileged. Anything else I'll treat as like, yeah, probably shouldn't have those permissions and I can take action on it. And that's the whole point of OWASP, is to look at insecure configurations and then take remediation action where possible to reduce the risk. Next one is supply chain vulnerabilities. Again, we'll go through this quickly, but a lot of it's already explained in the previous section. So things like Alpine image, any image really, like you don't want to bring it through a whole load of dependencies you don't need. So it's better to have a nice solid base image. Another example is even like small clusters. We talk about service dependencies. So I'll show that now in the next section. So, there's tools like KubeView. Again, I'm going to purely focus on open source here. But with these tools, you can actually see the dependencies between those workloads. And then you'll actually quickly see when you're trying out this tool that, yeah, there's all these sporadic, disconnected things that we don't actually fully understand. And this obviously increases the risk inside your environment. Another solution, because for each section, there should be, consultative solution-based approach. And since this section is on supply chain vulnerabilities, on the earliest possible process to do a container registry, you should be signing your images. Again, it's the validity thing is just making sure that it's been signed, it's verified, it's good to go inside your environment. And cosign is a brilliant open source tool for achieving that. So with that, overly permissive RBAC, I assume everyone has it, you're using it, but probably everyone doesn't use it in the way that, it should be configured. So there's different approaches here to, I guess for here, it's like monitoring RBAC. So, tools like RBAC Audit, they're specifically looking at the risky roles. There's tools like Kubiscan that are focusing on the permissions. And then there's tools like Crane, which is like visualize what is going on there. So it's very easy to use RBAC. You can see like the API example here with RBAC authorization, and you can just specify the create, read, update, delete, the CRUD actions that you want to, or verbs that you want to allow or deny for those workloads. Then managing it on scale, it gets harder. So that's why there's logic like role bindings. But obviously what ends up happening is you do one of two things. You either make it too restrictive and you can't do anything, or you make it too wide and you're not actually restricting users at all. So things like RBAC Audit that I mentioned a second ago, you can run a single line command, you can specify a bunch of feature flags, and then you get a nice report. And this is what it looks like. So actually, that is really hard to read because of the black, so apologies. But yeah, you see your cluster roles, cluster role bindings, and then it'll tell you, I can barely read that. But it ties to, what are the things it's allowing and basically what you should restrict and take action on accordingly. Whereas kubescan, that's looking at the permissions that were assigned. Again, similar idea, two different approaches to the same problem. What I think is, obviously, I'm not selling any tool here, so you can take whatever approach to those risky users or permissions. But Crane is a really useful tool for achieving this. So you can see with two very simple commands I've done in the past, where you can do a report where you just specify your cuddle context, and then you can actually see in the data visualization what are the connections between the roles that you've assigned to those users. And similarly, like if I want to generate that dashboard, yeah, I can just specify my cluster with the -c flag. Super simple, and then you get all that nice graph. And again, it's from here you can then take action on it. So I kind of approach or recommendation is to have some form of visualization tool to tell you where those risks exist, so you can take action. Because for sure, you're not going to use kubectl to check for whether or not you've overly permissive. There's lack of centralized policy enforcement. By default, yes, you do have an admission configuration within Kubernetes. There's tools like kube management that address the issue. So like you can manage multiple policies across different environments rather than doing it sporadically on each one, which you would have done with the admission configuration. But usually what ends up happening is people aren't using centralized policy enforcement. They're not doing the controls that they should. And that's where something like Falco comes in really handy. So because it's based on system call architecture, in the case of like, obviously we encourage people to use something like your admission control to say, disallow images from untrusted registries, and then it's a very simple process for what you do and don't permit. But with Falco, where it comes in handy is, for instance, if someone was doing something they're not supposed to be permitted to do, which is like modifying a config map and putting in private credentials and super insecure behavior, at least then you get that real-time detection as you see the source is taken from Kubernetes audit log. So you see that in real time, it tells you some insecure configuration comes from it, and then you can go back and actually build your constraints around that to actually restrict that behavior from happening. And again, if you're wondering how we define what is private credentials or anything like that, then obviously with Falco, you can create like macros, and inside those macros, you can define what are the objects that are contained within it. Yeah, inadequate logging and monitoring, it's baffling, but like obviously when you start off with Kubernetes, you don't have all this nice data visualization. It's just basically an empty environment. You just have the key components that operate it, like core DNS and so on. So the recommendation is to take, obviously, these open source tools when you're trying out. So Prometheus for metric scraping and understanding what is happening in your environment. So, monitoring what's going on, your introspection. You'd have Grafana more for data visualization. And then, as I mentioned again, Falco for that real-time visibility into what's going on in your environment. Now, because Falco is dealing with system call architecture, it's a great place to get going because naturally, any request that goes on inside the environment, you can see, like, for instance, OS-specific activity, container-specific activity. With the plugin architecture, you can actually see what's going on in your cloud provider and then stream that to the same environment. But things like Prometheus and Grafana, same thing. Exporters, you want to get it into a centralized view to understand what is actually happening in your environment. The different approaches here is, like, again, even down to your network policy implementation. So in this case, I just randomly chose Calico. I'm pretty sure I can do the same thing in Cilium. So, you can allow traffic that you permit or whatever, and it's all IP tables in the case of Calico here by default. So you can see the network flows that are happening in your environment. But you might also say if the front end, let's say a zone-based architecture. So you have DMZ, you have the trusted zone, restricted zone, all of that kind of stuff. If your front-end workload isn't supposed to talk to a back-end and they're labeled accordingly, then you might also have this action, say log, and then stream that off somewhere else so you understand, okay, yeah, the flow was allowed or rejected, but there was also a request going over which shouldn't between workloads, so it might be a sign of compromise. There's also the case of what happens if people are deleting logs. So again, Falco is a great example for, because it's real-time architecture, we can see actually when there was an example of trying to clear log activity and then putting it in a centralized view, because I don't know if this section, it's inadequate logging and monitoring, but I do feel like there's a need to have a centralized view for all of these problems. Obviously, Falco is great for the detection response, but forwarding it to a SIM, you can do simple STD out on that, and once you see it, it's like very small piece of code to do it, and then you can read the JSON output from that. So again, logging, when you think about it, you have Prometheus, metric scraping, Grafana, visualization. You can use any tool you want, even down to the network policy, but it's just important that you have these logs somewhere that you can actually go in and say, okay, this is an insecure behavior that's playing out in our environment. Broken authentication. There's not a lot to be said for this section, but it's self-explanatory. So, first thing is don't roll out your own, cryptographic modules if you don't really know what you're doing, and don't do something insecure. The other thing as well is as an entry point into an environment. I remember with the Tesla crypto mining breach that was some years back, it was the simple access point was through one of those Kubernetes dashboards. So really insecure, shared credentials, all of these kind of things are obviously best practices. But when it comes to authentication, how you access, the best approach is always to use some form of multi-factor authentication, more than just using a plain text password. As I mentioned earlier about the RBAC restrictions, like what the user can and can't do, that's perfect, because then if a user does want to go into something or make changes that they shouldn't be able to, once you define those create, read, update, delete actions on the user account or on the service account, then they are limited to what they can do, the blast radius within that environment. So with that, network segmentation, this sort of it's a long-winded section. I think you could almost do a whole OWASP on just network security within Kubernetes. The first thing I would mention is it's like a flat network design. So all workloads can freely communicate with each other. That's obviously fine. I mean, from an operational perspective, everything can communicate, and that's great. But it's very hard to define what are the controls that you should enforce, that everyone should have these set of best practices, because obviously everyone configures the networking different. There's different CNI providers, there's service mesh architecture, all sorts of things, and these are optional. I mean, by default, yes, there's a default CNI, and you can choose which CNI you choose, but obviously there's nothing forcing you to use a service mesh like Istio. I didn't even mention there, but there's Linkerd or Cilium service mesh. There's other options. So I remember looking at this micro survey a long time ago. I think it was from from KubeCon in Valencia. And it was around users that are actually using these technologies, network policy, creating default deny policies, or they're using service mesh. And there was always this sporadic difference between what you configure and use in staging versus what you actually operate in production. So everyone's tried out default deny. I think everyone here knows the simple logic of default deny. In reality, not everyone actually applies that in production, which is a scary thought. So this is a perfect example of something you could at L3, L4, like the network layer, everyone could enforce this best practice. And this should be something that is triggered from a control to say, look, you haven't applied a default deny. So the logic, if you're not familiar with networking in Kubernetes, is that you would explicitly allow traffic between workloads. So you say this pod with this label can talk to this other pod with this other label, or to a fully qualified DNS. But everything else that isn't explicitly allowed, then it should be implicitly denied. So in this case, you just specify, again, I use Calico. You could do the same with Cilium or a different provider. So in that network policy definition, you just specify ingress, egress, the inbound and outbound traffic. And because it has no control on it, what it's going to allow, it should drop that traffic. And you can do something similar with, the service mesh technology. I know that's going to be the HTTP GET post, the L7 traffic. But you can implicitly deny or explicitly deny, as you see with the example on the right. So, you should be applying default deny logic in both the network layer, but also you should be doing this on the L7 traffic. And then the last thing I would mention is, by default, traffic isn't encrypted. So all traffic in transit, it's basically accessible and readable. So, there's simple solutions. I think Cilium and Calico are doing the same thing, which is using a technology like WireGuard for creating those tunnels. And it's very simple. There's an example here with Felix, and you just make a patch command, and then you just say, okay, I want to have WireGuard enabled. Very simple. But again, it'd be the same for L7. If you're doing everything via service mesh, then you have things like mutual TLS for encrypting that traffic. But as a best practice, everyone really realistically should encrypt traffic in transit. And if they're not, it should be considered an accepted risk. With that, you have secrets management failures. There's fairly good examples here. So, again, by default, secrets aren't encrypted. I'll show an example of that, encrypting those secrets at rest. You should avoid credential sharing. That goes without saying. So, for instance, shared user accounts or service accounts, and they're accessing those same shared credentials. And again, the same example with Falco. If you don't have some way of encrypting, or you haven't done this already, then you should have something that obviously detects when an insecure behavior occurs. And this applies, we're talking specifically around etcd for this secrets management example. So if I go on to the next slide, very simple example. by default, there is actually an API that you can use. It's the API server config k8s.io. So with that, you can see here that you're parsing in, a base 64 encoded secret that you want to encrypt. And again, you use the kind encryption configuration for that. Pretty straightforward, but again, it's one of those things not everyone's doing. And from our threat research report, I can't remember what the number was around it, but yeah, there's a significant amount of environments that just don't encrypt secrets. So it's sensitive credentials, passwords, and like. And by right, that should be secured in the most secure way possible. Yeah, another thing again is when we're talking about backups, very easy to do, but by default, etcd does not do the backup for you. You have to choose how you're going to do that. Obviously, to avoid data loss, if something goes wrong with etcd, you lose that data. So that's a big issue. Same with TLS encryption. It's not enabled by default. So for the Kubernetes API server, you should be able to enable that and obviously rotate certificates where possible. Avoid using them sitting around for a long time in the environment. And the third part is not readable on screen. Oh yeah, anonymous authentication. You don't want non-authenticated users from accessing the environment. So it's simply just switching the flag from set to true to false. So with that, yeah, for the example there with etcd, you can use etcd as CTL, another one of those controls, and then you just specify snapshot save snapshot dd. So you can save the to a snapshot. You just specify the endpoint that you're going to do that for. TLS, it's another simple example. You specify the TLS cert file, and you also specify the TLS private key file. And yeah, for disabling anonymous authentication, I think it's just saying kubelet anonymous auth set to false. Pretty self-explanatory. So again, these are all examples of controls that can easily be applied in every organization, and you would have to have a fairly justifiable example of why you're going to accept that risk by not implementing these best practices. The next example is the outdated vulnerable Kubernetes components. One of the things I found kind of interesting was around like the second CVE there, which was the man-in-the-middle style attack. There's actually this CVE. It's been around for, I don't know, 3-4 years or maybe longer. But again, it's an unpatchable example that's shown up in Kubernetes. You can actually just look it up yourself. But it just allows the users to, I guess it was when they create the external IPs, there's just this way of like, spoofing or watching the traffic that goes on between it. So the only advice that was given actually on the CV disclosure was that you can apply like a constraint template around the creation of those external IP workloads, again, to limit that risk, but it's actually unpatchable. So currently to this date, I guess it requires a huge change within Kubernetes, which they're currently not willing to implement. And therefore it's left it in a situation where, you have to accept that risk or at least have something like managed policy to actually restrict said workloads from being created. Did I go through all 10? I guess we did. We went a little bit faster than I thought. So yeah, what's needed to address the risk? Obviously, you can just go to the website for OWASP and you can go through their list of controls they've specified. Naturally, not every example's there. They'll, like for each section, they'll probably put, like what I did is 2 clear examples of something you should probably not apply, like you shouldn't have an anonymous authentication enabled, or you shouldn't have privileged workloads, so on. And they'll give some best practice around preventing attacks. But if you look at, we built a policy framework within Sysdig, and you can see that so far, like 344 controls are specified in it. And that's, I guess, a big issue is that I can't possibly read out all 344 controls that will fall under this. But using technologies like Falco, it's a great way to understand what are these insecure configurations and then take action on them. I mentioned earlier, there's a bunch of different technologies for taking remediation or preventative measures. So we talked about network policy from the networking layer. We talked about using admission control for preventing or allowing what is trusted within your environment. And with this report, it's just a really nice way to drill into a specific section, like overly permissive RBAC configurations, and then actually see what are the 21 controls or whatever that relate to RBAC configuration. I guess I went through this a lot quicker than I thought I would. Naturally, I normally talk about this for an hour, but I thought in 35 minutes it would be not enough time, so I thought it would go a bit quicker. But the one thing I would say is A lot of the findings we had at the beginning, they're coming from the threat report that we perform at Statistic each year. I definitely recommend you can scan that QR code and actually look up the threat report. And the other one is just the OWASP risk report, in case you're wondering, well, why are we doing this or how we conducted these findings. We've also put into a kind of a nice, easy to read blog, obviously because there are so many different findings in it that will go into that policy feature. But with that, I guess we can jump on to Q&A if I'm not, moving a bit too quick.
If it's fine for you, let's go.
Cool.
Great talk, by the way. All right, we have now 3 questions, but I'm pretty sure if we have some time left, there's more coming up. The first question, and I could have asked it myself, how does Falco compare to Trogon?
Yeah, it's a great question, and being totally transparent about it, there are genuine merit to both. My master's I'm doing at the moment, I'm using both technologies for a very specific use case. So with Tetragon, both are based on system call architecture. So like the whole real-time thing, you get it in both of them. Where they differ is you saw with Falco, you have this like rules definition, so you can create like macros and lists and create like complex conditions to say, like we talked about, creating a workload that's privileged. You want to say, yes, the privileged action happened, but it didn't apply to these things I trust, and then there's a complex list I created within it. Tetragon just isn't a rules engine, so it's not designed for, you have tracing policy, so it's like tracing when something insecure happens. You even have preventative actions, which you don't have in Falco. You would insist it's secure, but in Falco, it's like a security camera. You can see when something's happening, and it gives you that deep visibility. Where Tetragon, yes, it can do tracing, and you can see in your terminal something insecure happened, and you have the added benefit of actually being able to kill a process with SegKill, which is really cool in other actions around networking. But you wouldn't have that deep rules engine to actually define a very specific action, like crypto mining connections over specific ports and IPs. You just have to create these complex lists.
Got it. Does Falco runs as a sidecar or as a daemon set?
Yeah, it operates as a daemon set, so it's a single service, and it's a cleaner approach.
Perhaps also we can add that Falco can run everywhere. So obviously also outside of Kubernetes also.
Yeah, absolutely. And that's a really nice part about Falco. You can run it on a standalone Linux box. You can run it on a Raspberry Pi. Obviously run as containerized workloads within Kubernetes. And with the plugin architecture, you're not limited to just monitoring what's going on in that system. You can actually connect to, let's say, AWS CloudTrail, Okta IDP service provider, or GitHub, and stream those events to it. So again, you can do introspection in what's going on inside your GitHub registry as well.
One last question, at least for now. Perhaps we may have one more coming up. Anyway, is there a good tool operator to continuously monitor all those criteria?
Yeah, I think the best example I provided there was the policy that the compliance report that we put together in Sysdig. I know it's more of an enterprise-y thing, so obviously I don't have an open source alternative to offer, sadly. There are tools like when we talk about like risky configurations, there's CIS. I know that's a benchmark, but a different benchmark. But like you can use a lot of tools that already exist, but right now there's no open source OWASP like compliance chart. So that is probably something we need to work to get out. Otherwise, you maybe purchase Sysdig.
Good call. Okay, we have a few minutes left. Is there any question in the audience? Come on, I'm sure you have. Raise your hand. Seriously?
And if anyone wants to talk about it outside, I'm available.
Then I have one.
Okay.
How about the sidekick thing?
Yeah. Yeah, of course. So what I mentioned there about the visibility part, Falco, you would go into your terminal and you can see what are the events that have been triggered within a specified time period, or you can stream them and show that like watch output and see it in real time, a bit the same as tracing policy with Tetragon. But then the member of our Falco team built this exporter type UI, so it's called Falco Sidekick. So it's a great way that you can visualize what were the events that were triggered. You get like data visualizations to see, for instance, categorization of the tags to understand like things like MITRE ATT&CK, where it would line, or even in this case, OWASP T10. But also it's a great way for like exporting, streaming those events to something else for like a SIM solution for further forensics. And it's also open source.
I have last one. Is there any UI in the open source that we can leverage for Falco?
Yeah, there's two ways. So with Falco, we have the Falco Sidekick, which is a great starting point. Or you can also stream those events to Prometheus. So we have documentation on actually getting those events into Prometheus so that you can actually build your own kind of data visualization around that.
I told you there's one coming up. We won't leave you. How would you integrate the OWASP philosophy with the shift left approach?
Yeah, it's a great question. It gets kind of confusing when you start going down this route because there is the OWASP T10 for Kubernetes, which is essentially just an orchestration platform. There's also a T10 for vulnerability management, which kind of ties more into that shift left to do with your registry. But actually right now, there's in progress OWASP for cloud native. And you can go to the OWASP website. It's in progress, as in it's not a finished thing. So they're looking for people to contribute to that. But that really does tie in the whole shift left to in runtime, because it's talking about cloud native. So cloud native for sure includes the cloud provider. It includes GitLab and GitHub. It includes everything from how you build the code, making sure it's secure before you push it into runtime, which is essentially Kubernetes at this point.
Awesome. No question in the audience. 3, 2, 1. Okay, that's it for now. Thank you very much for your talk. And please don't forget to rate all the talks you're attending.